Before we go into the next example, I just want to introduce some vocabulary and notation to you. Now, you've probably run into the term set in everyday life. You might have a chess set or a train set, or you could have a set of silverware, a set of golf clubs, a tea set. You could have a set of Pokemon cards. So you probably have a fairly good idea of what a set is. In mathematics, a set is just a well-defined collection of elements, and that's about it. The objects in a set are called elements. Okay, so the elements are the members of a set. Now, when we're naming sets, we oftentimes use an uppercase letter. If we're naming elements of a set, like an arbitrary element of a set, we would use a lowercase letter. Okay. Now, so let's take a look at applying these terms to the sets we were just working with. In example 1, we had the set of all students in the class. Some were business majors, some were freshmen, some are both, some are neither. Right? So we had a set of freshmen, we had a set of business majors, but then we had the whole set of students. Okay, so in example 1, the set of all the students would be considered our universal set. Okay, I'm going to talk to you more about that next time, but it's considered the universal set. So we use the capital U to represent the universal set, which in example 1 was just the set of all students enrolled in the class. Okay, so you could say that, let me just look at somebody. Liz Alley is an element of our universal set. So I could write Liz Alley's name in this space, and I know that she is an element of the universal set, which is the set of all students in this class. Okay, you could fill in your own name there. You are a member of this class, so you are an element of the set, the universal set, which represents the students, all the students in this class. Okay, so and then we defined a set F, right? Set F, the set F that we defined in example 1 was a set of all freshmen in the class, right? So I said let F be the set of all students such that S, the student, is a freshman. Okay, so what I want to do is I want to teach you how to read this notation. Okay, so what this says, this mathematical statement, F equals, and then we have curly brackets, and we have S, and we have this line, and so here's how you read this. So F is, okay, so the equals is basically is, the set of all, so these curly brackets, we can read it as the set of all. S, okay, so S is a general element in the set. Set of all S, such that, so this line right here means either such that, we can read it as either such that, or we could read it as given that. Okay, so that's what that little vertical line means. We can read it as such that or given that S is a freshman. Okay, so we could read this as F is the set of all students enrolled in this class, because that's how F is defined. F is a subset of the students of the class who are freshmen. Okay, or given that they are freshmen. So you would qualify to be in this set if you are a freshman. Okay. The same way down here, we're defining another set, B, and B we define to be all the business majors in the class. Okay, so we can read this statement as B is the set of all S is a student, an arbitrary student, such that S is a business major. Okay, so again, the vertical line, we can read it as such that or given that. Okay. Or in this case, I think I just said who are, but you can also say such that or given that. So B is the set, curly brackets means the set of students. S is a student, such that S is a business major. Okay. All right. Now we had some subsets, right? We had some other sets that were basically the combination of sets, right? We had the union of sets, where we look at all of the elements in both the freshman set and the business major set. They're either freshmen or business majors or both. So the union of two sets means that's the combination of sets of the two sets where either the student is an element of the freshman set or the student is an element of the business major set. Okay, so the union of F and B is a set of all students such that the student is an element of F, the freshman set, or, it's important, it's in bold, right? Or the student is an element of the business major set, or both. Okay, that's what a union means. In mathematics, we use this kind of this U shape. Okay, it's not a U with a tail like we would write, like a letter. It's just a cup, kind of a. It's just a U without the tail. Okay, so the union of F and B, okay, is a set of all students such that S is either an element of the freshman set or S is an element of the business major set, or both. Okay, that's what union means. The intersection, we also had some people in the intersection of the two sets, which meant that they were both freshmen and business majors. So the intersection of two sets, we use this symbol, this kind of upside down U, to represent the intersection of two sets. And we read it as and, okay? We read it as and because that means, the intersection of the two sets, F and B, are the set of all students such that a student is an element of F, the freshman set, and an element of B, the business major set. Okay, so to be in the intersection, you have to be both a freshman and a business major. So it's a very exclusive set, right? You have to be both. You can't just be a freshman but not a business major. You have to be both. You have to be a freshman and a business major, okay? Whereas the union is more inclusive. You can be either a freshman or a business major, or both to be in the union. But to be in the intersection, you have to be both, okay? You have to be only both, right? You have to have both qualifications, both attributes, both the freshman and the business major. So that's why we read the intersection as and, okay? And that's very important. I want to get you used to reading that as and, okay? And the union, we would use the word or. Okay, a couple more things, pieces of notation that I wanted to go over with you. One is a complement. So this word complement, notice it has an E here. This is comes from the word complete. Okay, it's not compliment with an I, like, oh, I like your hair today, it looks really nice. That would be a compliment with an I. A complement with an E means it completes. Okay, it's the kind of the opposite. It's the other half of a binary choice. Okay, so for example, F complement, those are all the students who are not freshmen. Okay, so you're either a freshman or not a freshman, right? And so F complement are the juniors and seniors and sophomores, right? So if you're not a freshman, you are part of the F complement set, okay? F complement, essentially, you can read it as not, okay? So it's a set of all students enrolled in this class who are not freshmen, okay? That's what a complement means. It's just the opposite. It's the other part. Because basically we treated freshmen as being a binary choice. You're either a freshman or you're not. So if you're not a freshman, you're not in the freshman group. So that would be the complement of the freshman group. All right. And finally, we have this kind of operation N on the set. So if we have N of a set, we're just asking what is the number in that set. So for example, in our freshman example, we had 19 students who were freshmen. Okay, so the number of students enrolled in this class who are freshmen is our 19. So that's how you would read that, this N of F. You would read it as the number of students enrolled in this class who are freshmen. Okay, the number in that set. All right, so before we go on, I just want to go back to example 1 quickly, and let's talk about how we would name those sets that we were asking about in example 1. So let me go back to example 1. Let me go back up here. All right, because we had, we had some sets here, and oops, I'm gonna go like that. Okay. Oh, what's going on here? Oh, all right. There we go. All right. So remember example one. The first question was asking how many students are enrolled in this how many students enrolled in this class are freshmen or business majors? So what we're asking for in that example was we were asking for the union of the sets, F union B. Okay, we called F the set of freshmen and B the set of business majors. So that's what we were asking. So the number in F union B is equal to 24. So I could actually write it that way. I could write the number in F union B is 24. The second question is asking how many students in the class are freshmen and business majors. So again, we're asking for the intersection. All right, they have to be freshmen and business majors. So we could write that the answer to that as the number in the intersection of F and B is 11 students. And then the next one, how many students in this class are freshmen and not business majors? So how could we write that? They're freshmen, so they're part of the freshman set, and not business majors. So and is an intersection, and not business majors would be B complement. Okay, so what we found in this question here was the number of students in the intersection of F and B complement. All right, so they're freshmen and not business majors. That's how we would read that. And the last question, how many students enrolled in this class are business majors and not freshmen? Well, okay, so these were business majors and, so intersection, not freshmen. F complement, right? Not freshmen. Okay, so that's how we could write that set. It's B intersection F complement. And what we found was the number of students in that were business majors, B, and intersection, not freshmen, so F complement. All right, so let's go on and do some more examples. I'll meet you in the next video.